All right, good morning. So the measure of lines and measure of angles and stuff starts really coming into play as we're talking about this section in particular. All right. So line and angle relationships. So looking at this cube or rectangle, it doesn't matter, but looking at this, you have different types of lines that it's talking about. You have a perpendicular line, which is two lines that intersect to form a 90-degree angle. Okay, so for instance, line AC intersects EC, and this would form a 90-degree angle because remember that a cube or a rectangular prism, that the faces are squares and rectangles which have to form a 90-degree angle. So these two lines are going to intersect or be perpendicular and form a 90-degree angle. Now, skew. Skew are two lines that do not intersect and aren't parallel, okay, but are in the same plane, okay? So they're two lines that are not ever going to touch, and they're not parallel, okay? So for instance, CE and BD are skew. They're not in the same plane, and that's what I meant to say earlier. They're not in the same plane, they're not parallel, and they're not perpendicular. So they're known as skew. Whereas last one is that you have two lines that are parallel. Okay? So AC and BD are parallel, CE and this line here are parallel, AB and CD are parallel, AC and BD are parallel. All right? There are two lines that are in the same plane that are never going to touch. Okay? If there are two lines that are not in the same plane and are not going to intersect, then they're known as skew. Okay? So, CE and BD, as I said, okay, are skew. AC, BD are parallel. And then AC and AB are perpendicular. Okay, and perpendicular is going. This is what the symbol for perpendicular looks like. This is the symbol for parallel, and skew doesn't have one. You just say skew. Okay. Now, what does this mean? Why do we care about lines that are parallel, perpendicular, etc., or lines that intersect or don't intersect? Well, these lines form properties for angles. Okay, so if I have two parallel lines, okay, and they're cut by what is known as a transversal. A transversal is a line that intersects more than one line, okay, or that it only intersects one. Okay, but it's a line that intersects another line. Okay. Then what happens is you form these, you form properties for the angles. So for instance, adjacent angles are common vertex and side, but no common interior angles. So for instance, you have these two lines here that intersect each other. All right. And they form what are known as adjacent angles. So angle 2 and angle 3 are adjacent angles. They're also supplementary from the previous section, meaning that these two lines are on either side of each other. Okay, they're adjacent from each other. They have a common vertex, but no common interior point. So you have these two angles that kind of have the same vertex. Remember, the vertex is the point where two lines are connected, forming an angle. Okay? So 2 and 3 are adjacent angles. 1 and 4 are adjacent angles. Then you have something also called vertical angles. Vertical angles are angles that are directly across from each other. They share a common vertex, all right, because of two intersecting lines. So 2 and 4 are equal angles because they're vertical angles. 1 and 3 share the same vertex and are vertical angles because they're directly across from each other. Okay? 1 and 4 are adjacent. 4 and 3 are adjacent. 1 and 2 are adjacent. But 1 and 3 are vertical, and 2 and 4 are vertical. But 1 and 3 is equal to 1 is equal to 3. 2 is not equal to 1. Okay? But 2 is equal to 4. Vertical angles are directly across. Okay? Now, also, when you have two parallel lines cut by a transversal, this is a transversal, okay? And these are your parallel lines here in red. When you do that, you form what are known as alternating interior angles and alternating exterior angles. So let's talk about the interior. Interior meaning inside. So inside the parallel lines, you have alternating, meaning how do I best explain this? Every other or other side, okay? So alternating interior, 1 is equal to 4. So angle 1 is equal to 4. They're alternating interior. They're on opposite sides of the transversal, okay? The same transversal. So 1 and 4 are equal. 2 and 3 are equal, okay? These are alternating interior angles. Notice that 1 is on this side of the transversal while 1 is on the other side. Okay? Another property, the exterior. So alternating exterior angles, once again, opposite sides, but they're on the outside of the parallel lines. So you've got your two parallel lines. You've got your transversal. So on this side of the transversal, on the outside of the parallel line, 4 and 2 are going to be equal, because if 4 is here, alternating means it needs to be on the other side of the transversal and on the outside of the parallel line. So 4 and 2 are going to be equal. So on the opposite side, 1 is going to be equal to 3 because it's on this side of the transversal, which means that 3 has to be on this side of it and on the exterior. Okay? Then you have what are known as corresponding angles. Okay? So corresponding angles are angles that are, one's on the outside, so one's on the exterior of the parallel line, and then one is on the interior, but they're on the same side of the transversal. Okay, so here are your two parallel lines. Oops. Here are your two parallel lines. Here's your transversal. 1 and 5 are going to be equal to each other because 1 is on the exterior of the parallel line and equal to 5, which is on the interior of the parallel lines and on the same side as the transversal, whereas 2 and 6 are the same thing. 2 is going to be equal to 6 because 2 is on the interior of the transversal and on the same side as the exterior 6. Okay? So it's a lot to process. It's a matter of just kind of going in and looking at the different angles, seeing if you can figure out what the which ones are equal to each other, look at the properties, kind of look at some more examples. So do your best on the examples, come in with any questions you might have.